Students, whatever homework is given to you, you have to submit it on the very next day between 8 am to 1 pm to the given WhatsApp number, and it is compulsory to submit your homework as your attendance will be marked on the basis of your submission.
Good morning, dear students. Hope that you all are fine. Today we are going to see about the real numbers second topic, that is fundamental theorem of arithmetic. Previous lecture I have explained to you about Euclid's division lemma. So right, what was that? If a and b are two positive integers, how can you write divisibility of integer like that way? A is equal to b into q plus r, where r is 0 less than or equal to r less than b, where a and b are the dividend and divisor, q is the quotient and r is the remainder. Using this Euclid division lemma, you already studied the previous lecture that how to find out the HCF of any two given numbers. Okay. Now let us start another topic of this chapter, that is fundamental theorem of arithmetic. Before this, I want to explain that what is prime number and composite number. Okay, you might have learned in the smaller classes prime number and composite number. What's prime number? The prime number is the number which having only two factors. Which are the two factors? One and the same number. For example, 2. 2 is having only two factors. Which are they? 1 and 2. 3. 3 is also having one factor. Which are they? 1 and 3. Same way, 5, 7, 11, 13. These all are having two factors only. One factor is 1 and the other factor is same number itself. That type of numbers we call by the name prime numbers. Now, next number, what is that? Composite numbers, which are having more than two factors. That means, for example, 4. If you have taken the example as 4, so there are factors. Which are the factors? 1, 2 and 4 are the factors. That means that is known by the name composite numbers. If you are taking 10, 10 also having 1, 2, 5 and 10. They are the factors of that particular number. From here we can understand one more thing, that 1 is neither a prime nor a composite number. That also you have learned in the smaller classes. Now let us look at this fundamental theorem of arithmetic. Here prime number and composite number, the statement is coming. That's why I explained to you that what is prime number and what is composite number. What's fundamental theorem of arithmetic states that every composite number can be expressed as a product of primes. That means every composite number. That means example 10. 10 you can write it as 2 into 5. 2 and 5. That means they both are prime numbers. So you can express, you can factorize every composite number as a product of its prime numbers. That means every composite number can be expressed as a product of primes, and this factorization is unique. That means one and only factorization can be done for one number, and from the order in which prime factors occur. That means if I can write 10 is equal to 5 into 2 also I can write. Here 10 is equal to 2 into 5 also I can write. Here 21 I can write as the 3 into 7. Here 7 into 3. Both are correct only. Therefore we can say that apart from the order it can occur, the factorization is unique. That means every composite number we can express in the form of a product of prime numbers. And next one is that what is prime factorization? Prime factorization means writing, the process of writing. That means a composite number, how can you write in the form of a product of primes? That is known as a prime factorization. The most familiar to this word factorization in the previous class you are. Prime factorization means you are writing a composite number as a product of prime numbers itself. Now next one is that factor tree. Factor tree means just if you are going to find out any numbers factorization, composite numbers factorization. Suppose I have written here 40. 40 number I have to factorize. So I can make it in a model of a tree and then I can find out the factors. How it will be? 40, that means it can be divided by, I am starting with the smallest prime number. So which is the smallest number divisible by 40, that is 2. 2 is divisible by 40. That means 2, how many are there? 40? 2 20s are 40. Then again 20 can be factorized as 2 10s are 20. Again this 10 can be factorized as 2 5s are 10. Then last factorization is that 5 1s are 5. Now look here, these are the factors, prime factors of which number? 40 number. So 40 is equal to 2 into 2 into 2 into 5. So you can write that it's a product of prime factors. That means 40 is equal to 2 into 2 into 2 into 5. Correct? I started from the smaller number, smaller prime number only. You can start with 5 also because order you can change yourself. But I have written it as in smallest number first and that way I have written here. 40 is equal to. So this type of tree you are making, this is a type of a tree and that is why it is called as factor tree. So you can make it as a factor tree, otherwise general factorization also will be done for this case. That means smaller classes you have learned like this is a factor you have to do 40, 20, 2, 10, 2, 5, 5, 1. This way also it will do, this way. This is a factor tree model I have made this one. This factorization of the number 40. Clear for you children now? Now, this fundamental theorem of arithmetic, for what purpose you are going to use it? So what's the purpose of that? If you are going to get 2 or 3 numbers, if you want to find out the HCF already we can find out by Euclid's division lemma also, but there are only 2 positive integers are given, then only you can find out the HCF. More than 2 numbers are given, so by Euclid's division lemma you cannot find out the HCF. So by using the fundamental theorem of arithmetic, you can find out the HCF and LCM of any 2 numbers, 3 numbers, how many numbers if it is given, you can find out the HCF and LCM. HCF already I explained yesterday. What is HCF? HCF is the highest common factor. What is LCM? That also you know that least common multiple of that numbers. Whatever the numbers are given, that. Let us see how to find out HCF and LCM by using the fundamental theorem of arithmetic. So now you make clear that what is meant by fundamental theorem of arithmetic, what is meant by prime factorization, how can you make a factor tree for each number, that means for each composite number. So what is fundamental theorem? Every composite number we can express as a product of primes, and apart from the order which the factors can occur. Clear for you children? Now using fundamental theorem of arithmetic, how can find out the HCF and LCM of any 2 numbers? Okay, for that purpose I have taken that exercise 1.2, question number 2, sub question 2. That means find the HCF and LCM of 510 and 92. 510 and 92, how to find out the HCF and LCM. So first part you should do that according to the fundamental theorem of arithmetic. This composite number you have to express as a product of primes. For that purpose I have made a factor tree for both the numbers 510 as well as for 92. So 510 I have made that factor tree like this way. That means first prime factor I taken it as 2, then it will be 255, then 3, then 85, then 5, then 17, then 17 and 1. That means here you can say that 510 you can express as the product of primes, which are they 2 into 3 into 5 into 17. Same time 92 also I made the factor tree for here also that one. 92 is equal to 2 into 2, then 46, then 2, then 23. 23 obviously it is a prime number only, therefore it does not have any common factor. That means the 23 ones are 23. Finally you have written that factor tree also here. 92 is equal to 2 into 2 into 23. That means you can abbreviate this one as 2 into 2, you can write as that 2 square into 23. Clear this much? Just I have made the factor tree and pointed out that prime factors in the form of product of the primes. Clear for you? From this data, how can you find out the HCF and LCM? Okay. Then just concentrate here. What I am going to say is that HCF means product of the smallest power of each common factor. The smallest power of each common factor in prime numbers. That means you can see here that 1, 2 is here, here also 1, 2. And 3 is not here, 5 is not here, 17 is not here. Same way 23 also not here. That means here too both the numbers are having the prime factors 2. But only 1, 2 is common in both. That means smallest, which one? Smallest power of each. That means here 2 raised to 1 is there, here 2 raised to 2 is there. So which one you will take into account? You will take only 2 raised to 1. That means smallest power of each common factor will be in the prime numbers, that will be the HCF. So what you can write for HCF? HCF is equal to 2. Clear children? Now come to next LCM. LCM means you have to take the product. Maybe many numbers, prime numbers can come as the LCM. The product of the greatest power of each prime factors. Greatest power. That means you have to just go through what are the prime factors here in this factor tree. 2 is there, 3 is there, 5 is there, 17 is there, 23. All things should write. And especially if both the numbers, if one factor is, that means repeating. That for example here 2 raised to 1 is there, here 2 raised to how many other? 2 raised to 2. So that one only you have to take into account. That means LCM will be all the numbers should write here. All the prime factors 2 into 3 into 5 into 17 into 23. All prime factors are written here. From both the factor trees, whatever the factors you got, that all you write down. Now you have to check that in which prime number, in which composite number more prime factors. That means 2 is 1 here, 2 raised to 1 is here, here 2 raised to how many are there? 2. So that you should take for that LCM. That means LCM will be 2 square into 3 into 5 into 17 into 23. This is the final answer for the LCM of these two given numbers. That means 510 and 92. What's the answer? 2 square. 2 square why has written? Because here only 2 1 times are there. Here 2 times. Here already in LCM written that product of the greatest power of the prime factors involved. That means 2 raised to 2 into all the prime factors you have to write down. It's very important thing you have to notice here for LCM. All the prime factors 3, 5, 7, 23, 17, 23. But if any prime factor is repeating in both, highest power you have to take for the LCM. Now clear for you children? Then you multiply it and then write down the answer for this LCM. Now look at this one. This also was exercise 1.2, question number 3, sub question 1. Here 3 numbers are given. You have to find out the HCF and LCM. The 2 numbers already explained. Now 3 numbers if it is given, how can you find out the HCF and LCM? By prime factorization method. 12 you factorize like this way, 15 you factorize like this way, 21 also factorize like this way. Clear? Then I have written here that 12 is equal to 2 into 2 into 3, 15 is equal to 3 into 5 and 21 is equal to 3 into 7. Now look at the HCF. HCF means you know that highest common factor. In these 3 terms, in these 3 numbers, one number is common, which is that 3 only common. And here also 3 raised to power 1, here also 3 raised to power 1. Here also 3 raised to power 1. That means highest common factor is equal to 3. Now for LCM what will you do that? LCM means I told you that all the factors you should write down. What are the factors you should write? 2 you have to write, 3 you have to write, 5 you have to write, 7 you have to write. And among these any numbers power is more. That means here prime numbers power 2 square. Here it is coming 2 square into 3. That means here power of 2 is 2. Therefore, that one you should take into account. Remaining all having here also 1 3, here also 1 3. 3 is 1 only, more than that power is not there. 5 is also you have to apply here, 7 also. So you might have a confusion that here 5 is not there, here in this 5 is not there, then also you should take into account of LCM or not. Yes, I already mentioned to you that all the factors should come in the LCM. And then after that, after all writing all the prime numbers, prime factors, then you have to check that any composite numbers inside that prime factors degree is more or not. That means power is more or not. Then that you should write here. So here I think so 2 square is there. Therefore we have written it as 2 square. 2 square into 3 into 5 into 7. Then you multiply it and write down the LCM. Okay, clear for you? One more point you have to note down here, that if you find out any two numbers, HCF and LCM you have find out, so there is a relation between HCF and LCM and that two numbers. That means HCF of A and B and LCM of AB. Then if both are multiplied, so it will be is equal to the product of the numbers. Let us check whether it is correct or not by doing a sum. Okay. So suppose I have to find out the HCF of 6 and 20 as well as LCM of 6 and 20. So 620 I have factorized it proper way, and after that I have written HCF. Here you know that HCF will be only 1 2. 1 2 is common, whether it is having 2 square, here only 1 2 is there. For 1 2 is common factor, so you will write that HCF as 2. Same time LCM. LCM I told you that all the factors you should write 2, 3, 5. All factors are written. Then in the here only 2 raised to 1 is there. Here how many 2's are there? 2's are there. Therefore you will take that one only. 2 raised to 2. Into 3 into 5. How much 2 is coming? 60. Now HCF and LCM you multiply. What's the answer for that? 2 into 60. What's the answer you are going to get? It's equal to 120. Same time, the numbers also you multiply. So what will you get? 6 into 20 is equal to 120. That means both sides are equal. That means HCF of AB and LCM of AB multiplied. Then A into B you are going to get. Sometimes using this relation, these three data will be given. You have to find out either HCF. Yeah, these three data will be given. You have to find out the LCM. Like that if the question is come. So you have to use this formula and then find out according to that. Now look at the question number 7 of your exercise 1.2. It's an important sum for you. It's a practical application of LCM only. Here two persons, Sonia and Ravi, they are going to complete one circular field. That means they are going to round a circular field. Sonia takes 18 minutes to complete one round. Same time Ravi takes 12 minutes to complete one round. So you have to find out, the question is that how many minutes will they meet together? After how many minutes they will meet together? That is the question. That means first round when she is completing, so Sonia will 18 minutes will be over. Second round when she completes, how many minutes will be taken? 36 minutes. Third round when she completes, 54 minutes. She will complete round number 3. For Ravi, the same time. First round he completes by 12 minutes. Second round he completes by 24 minutes. Third round he completes by 36. So you can see that here also 36 has come. Here also 36 has come. That means after 36 minutes they both are going to be meet at the single point. Is it right? That means for Sonia she will finish only 2 rounds. But for Ravi he is going to finish 3 rounds. But also he takes how much rounds? How much minutes? 36 minutes. And this person also takes 36 minutes. That means what you are going to find out here, these are the multiples of 18. Is it right? 18, 36, 54 are the multiples of this number. And Ravi, 12 minutes. 12, 24, 36 are the multiples of. And what is this 36, 36 here? These are this one is the LCM of these two numbers. Is it correct? 18 and 12, sir. LCM is that 36 and 36. Clear for you? That means what you are going to find out in this question, you have to find out the LCM for both the numbers. Then you will get the answer for that. 18 and 12, you find out by prime factorization the number. So you are going to get the answer 36. That means after 36 minutes, they are going to meet together. Anyway, they will complete 3 rounds at the same time. But Sonia, she will complete only 2 rounds. That's not a matter for us. So how much time, after how much time they are going to complete? That is the question. Now you clear this sum, I think so. It's very important sum. This is a practical application of LCM using this fundamental theorem of arithmetic.